Welcome back, class. Today we're going to be talking about batteries, in particular about the information covered on task sheet 150, 151, and 152. Now, this includes servicing and replacing the battery. It includes actually charging the battery and finding what rate you need to use to charge the battery. And lastly, jump starting the battery. Now, we're going to cover some of this out of order in the order you would actually do these procedures in a shop or to your own vehicle. That way you're being efficient and you're not being counterproductive. The only reason they're structured like this in the material is so that you learn and understand each independent operation. But in reality, all of these operations work together as a whole system, just like the whole car does. The wheel and the lights don't just work alone, they work together with the rest of the car. So let's get started. Today we're going to be checking the battery, seeing what needs to be happen here on my daily driver, which hasn't been driven. So luckily it unlocks and we're going to find out if it actually starts. We're going to notice the little tiny warning lights come on. I try to crank it, they go away, it doesn't crank. So here we have a Fluke DMM, it's model 88V. So it's automotive voltmeter specifically for techs. We're gonna first change from off up until we hit the DC volt symbol. Now we're gonna make sure that we have our two leads plugged in the correct orientation. So we have the COM line hooked up with the black lead, and then we have the voltage, ohms, and continuity testing set up for the red lead. So we're good to go. So we're gonna take these two leads and contact the red lead with the positive side of the battery and the black with the negative. Because whenever we're measuring voltage, like we set the DMM to, we're not measuring through a wire, but we're measuring across 2 points. So that's what we're gonna be doing across the battery. With that set, it's pretty hard to see, but the DMM is reading 10.09 volts. So it's really low because it's been sitting and it's been running a few programs and stuff while it's been sitting. So in this battery only labels the cold cranking amps and the RC reserve capacity. So it's 500 cold cranking amps, and it's kind of hard to see probably in the camera. 85 is the reserve capacity. Using those numbers now, we'll be able to calculate what is the correct charging rate for this battery. We can either move the whole car inside and charge the battery with it in the car, or we can remove the battery, take the battery out, and charge just the battery by itself indoors. And that way we don't have to move the car or jump start the car. In that case, that's what we're going to be doing. But we first want to actually check and inspect the battery, making sure our hold down here is tight on both sides. We don't want the battery moving. We don't want it hitting the firewall or hitting, in this case, the strut tower in front of it. As well, we're looking and we're taking a close look at the terminal ends and the battery cable ends. And then we're looking at the positive and negative, making sure there's no acid buildup. In this case, the electrolyte solution's sealed, so we can't replace it, we can't service that or add to it or check if it's low. So that's something kind of out of our possibility. But we can also check the date sticker here. It does have a date sticker. Do note though that the date, this is supposed to be the date the battery is manufactured, and it's supposed to be marked. And then the date that it was installed should also be noted, because those dates can vary anywhere from a week or two to months. And if the battery's been sitting around for months, not being put in the car, it's probably not as good as a brand new one that's only a week old, been sitting on a shelf in a parts house 1 week. In this case, the battery hold down to remove it, as well as both of the terminal ends, use one size nut and bolt. So that's really nice. They use a 10 millimeter outer side. So we're gonna need a 10 millimeter socket. And you can put 10 mil on a little speed handle if it'll fit in there. You can put a 10 mil socket on a nice little ratchet. It's easy to get in there. Or if all else fails, you can always go for the nice opened-in wrench. All of these tools are metal. So we do want to be careful that when we're removing the battery, we're only touching the terminal, we're not touching anything else, because otherwise, if we touch the body or another metal part of the car that's grounded from the positive side, we can create an arc. To prevent doing that though, we're going to start by actually removing the negative terminal first. So in this case, we're just going to use the open-end wrench, just loosen up the nut on the actual clamp from the wire harness, and we're going to remove the negative harness first. This way we've removed ground, so that way, unless I touch from here to there on the battery, positive to negative on the battery, I don't have to worry about arcing over. Now I'm going to do the same thing and loosen the positive terminal as well. And in this case, I'm just using the wrench because it's the most basic tool you have there. And there are quite a few batteries where an electric little driver, which some people prefer to use, a ratchet, or a speed handle will not fit. And then you're out of luck. So now we've moved both of those. We're going to pull those harnesses off to the side so they don't touch it. And we're going to take out the actual bracket. In this case, I'm just using the speed handle now because these are easy to access and the speed handle is not going to hit anything. Do note, I'm not taking these nuts all the way off. I'm just loosening them enough to get this bracket off. You don't want to take these all the way off. If you do, you'll drop the actual hook that holds the battery in, and you'll see that in just a second. So I'm going to pull down and twist, and if you look down inside the little tiny hole these slide into. So I'm going to do that for the front and back, and I pull the bracket out. So this just hooks in the bottom, and you can twist that little hook, but I definitely don't want to drop that down anywhere in the car and lose it or not be able to get it out easily, wasting my time. Now I can take the battery. If you have a battery grabber, you can use it. Do be careful, some batteries are pretty heavy. This battery is pretty light for a car battery. It's only about like 35-40 pounds. Others can go up to about 110 pounds for the battery, so be careful. Make sure you're in a fairly safe position and you're using good posture. All right, now with the battery out of the car, it's time to actually charge it. So in this case, I didn't just set it on the cement floor. No, we don't do that. Temperature difference between the cement and the ground and the battery can change drastically, especially when we think about how much time it actually takes to fully charge a car battery. This isn't a 20, 30, 40 minute charge. They don't charge that quickly, so it's going to be hours. If the battery voltage is really low, it can easily take over 8 hours to charge the battery. So in this case, we're leaving it off the ground so that the temperature stays nice and level during the charging period. It's a wooden workbench, and then on top of the wooden workbench, I have a foam mat from Hunter Engineering with kind of like a clear protective layer on it. So in case it overcharges or some reason acid comes out of it or something, I've protected the workbench to keep it from soaking into the wood or anything. Now I have this charger here. This is a really old charger. It's a lot older than I bet a lot of my viewers and I am, but it still works really well. Now this charger is preset. I'm not going to show you because you guys need to do the math and the calculations to find the charging rate. Plus this charger is really old, so it doesn't have as many options as a newer charger does, but it still does have options. Now before we do anything, before we start playing with these little switches, before we hook it up or plug it in, we need to think about what are we going to do with all these wires. So the last wire we want to be connecting is the power cable for the charger. This is the last thing we do. We've plugged this in the wall all the way at the end. So we don't do that right away because if the charger has a short circuit or an issue, or let's say the switch doesn't work and it's stuck in one mode, we don't want to be electrocuting ourselves or creating sparks with these two ends all over the shop or damage our battery. So this is the last thing we want to do, and that's a safety precaution. So before we plug that in, we're going to take our two leads and hook them to the battery. In this case, it's not plugged in. There's no capacitance left in the charger. No arcing. They're good. They're safe. I can touch them both. I'm okay. So I'm going to take the red one and I'm going to hook it to the battery. I find that little plus sign, that positive mark, connect it to that side. Then I'm going to take the negative side last, just like we would jump starting a car. Negative last. When we're taking it out, we unhook the negative first. So found the negative sign, I hook up the black negative lead. Now that the battery's hooked up, I can take the actual outlet plug. I can go over to my power strip over here or my wall plug, the extension cord, wherever you're at, and charge it. Do note though that you don't want to have a ton of chargers all hooked up to the same circuit in a house or building, or you're really likely to overload and pop a breaker. And you'll come back a day later and your battery isn't charged one bit. Now with that set up, the charger is going to have at least 3 options. It'll have a start, an off, and a charge mode. This is an older charger, so that's all it has. Newer ones will actually have a charge setting. So in this case, if we do actually hook it and hit start, you'll see we jump up to about 30 DC amps, which is way more than we want to charge our battery at. That's for a short period of time just to get the car running. In this case, off, we have 0 amps. We saw the 2 little alligator clips. They were safe. We could touch them together, no sparks. This one, you do have a charging one, and it does also show you the charging rate. So this is a 10 amp battery charger. It does have 30 and 50 amps for starting, but for charging, we're gonna use 10. So in this case, we'd turn it on to 10, and we let it sit. We'd go do other stuff. We would keep an eye on this throughout the day in the shop if we're working out here, making sure that we don't smell any sulfur smells, or that the circuit breaker pops, the charger turns off, or the battery starts swelling out. All of those are very, very bad. We don't want that happening. Do note, in this case, I did not hook up a memory saver to the car because I wasn't worried about saving radio codes or anything. I just need this battery charged so the car will start. Now, if you're doing this to a customer's car or your own car, if you have a memory saver, feel free to use it, but do note that when you're actually charging the battery, it'll take much longer to fully charge this battery than the memory saver will last, so it's not going to help you. If you're just replacing this battery, we took it out of the car and then we're taking a new battery and we're putting a new battery in, then go ahead, use the memory saver, because at most that should be taking you 10 to 15 minutes. All right, fast forward. Now our battery hopefully should be charged, but before we can check the charge of the battery, we got to take off these cables. We got to turn the charger off and get rid of that so that we can use the DMM to measure voltage across the positive and negative terminals. Now first we're going to turn the actual charger off, so we're going to hit the off button, turn it off. Now before we take off these leads, we're going to follow the reverse order that we followed before, connecting these leads. So the first thing we're going to do once it's off is now unplug from the power strip, bring that over. Next we're going to actually unhook the negative and then the positive. In this case, it's off, there's no power, there's no arc, we're safe, we're good to go. Now we have the battery here, so now we're going to turn the DMM on, and what we're going to be checking again is DC voltage. So on this one, it's the second little click there, and you shouldn't just leave this on the battery. It's not the best 'cause it falls over, so we're going to leave it on the bench here. Now remember, look for the negative sign and the positive sign, because now neither side's red or black. Tech tip is, most batteries that have post mount terminals, not thread in terminals, these are the post mount terminals, they're round like a post sticking out of the ground, the negative is smaller in diameter than the positive. So if you measure them both, you'll notice the negative side is smaller, positive side is bigger. So that's another way to tell. Measuring across the terminals and across the battery, we're measuring 13.2 volts. So our battery now is fully charged. Now it's time to take this battery and put it in the car. GoPro, stop recording. Little tech tip here, using a DMM. You have these leads, and like this fluke meter has an internal fuse. In case you accidentally touch something wrong or you arc across, it'll hopefully help you out. But that fuse is a special fuse, and it's not like easy to actually change. So, and some DMMs, cheaper versions, don't have internal fuses or a safety fuse. They will actually just damage the circuitry inside, and if it's a higher quality one still, they're expensive. They can be upwards of $200, $300, $400. So in order to do that, we've taken the leads here, we've actually added an inline fuse. In this case, you can easily replace this nice 10 amp fuse. If it blows, we're keeping our actual DMM safe. So we can just remove this little tiny fuse and replace it and not have to worry about damaging DMM. If your leads don't come with these, you can order leads that already have an inline fuse attached, or you can just get an inline fuse adapter and add it to your positive lead. I recommend adding it to the positive lead because usually that's the side that's actually the fuse is going to blow on first. Whereas if you put it to the negative, it's going to take a little longer for the fuse to blow. Because if you rotate and you put the battery in backwards, so I put it in this direction, I can actually hook up the battery incorrectly, which can cause quite a bit of damage. Luckily on some vehicles, the harness will not reach or fit if you put the battery in this way, but on a lot of cars, it still will. In this case, it actually would. So we definitely want to make sure we don't do that. Now that we've got it facing the correct direction, we're going to take our hold down, actually line it back up, let it sit. We want to make sure both of these hooks get attached. So the front one's pretty easy. The back one, it's just better just to feel and then get it attached. Now with those set, we're going to put tension on the actual mount and just tighten both the nuts down. Until it holds. And I'll do the same for the rear. Don't put the hold down too tight because you can actually damage the case, cause the battery to leak or bend the bracket. Now we're going to take the positive cable, the red one, and actually attach it to the post and the terminal end on the battery. So making sure if there's any other wires, I'm not crossing them over, and just tightening it down. Don't over tighten the actual clamps on the harness ends either. You can damage the terminals on the battery, and you can stretch the clamps so that they no longer fit or they tear. Once it's tight, I want to wiggle around, make sure it can't spin or come off or come loose. Next, the last thing I'm going to do here is attach the negative terminal, and that's so that when it touches, I have less chance of major arcing. Arcing is just when you have sparks coming from electricity. So same thing here, bring it down and then just lightly tighten it with the ratchet. This doesn't need to be super tight. You don't need to get a breaker bar out. There, and it's tight, the battery mount's tight. Now, let's find out if the car actually starts. So there we go, the car actually starts now. All of our warning lights turn off like they're supposed to, and we're good to go. Hopefully you learned something in this video. And if you did, give it a thumbs up, drop a comment, subscribe, and hit the notifications bell. And tell all your other friends to subscribe and make 4 fake accounts so you subscribe too.